So I believe that test-driven development is the easiest way to program. It's also a lot of fun. I didn't always believe this. I used to believe that testing was boring and that test-driven development seemed really hard. During my most recent stint as a manager, before I dove into Ruby on Rails, though I had an engineer who brought unit testing into my team, and I ended up relying on that a lot. And so when I dove into Ruby on Rails, I thought, okay, I'm going to do TDD and steel myself to learn this thing that seemed hard because I thought this is good for me. And then this is what I thought I was going to get. I was able to build tests through this methodology. I was delighted to realize that I was completely wrong. Not that we don't create tests in test-driven development, but it's really about design. It's about understanding what your code does, and surprisingly to me, it's about collaboration, even if you're not doing pair programming. So how does this work? Before I dive into how TDD works and how you learn about it, because the way I learned about it was I started pair programming with somebody who was passionate about it. And that's the easy way to learn. If you end up, working side by side, day by day with somebody who knows all its ins and outs and all of its patterns, that's a wonderful way to learn. In fact, that's the way most people, I think, really learn how to do this stuff, this oral tradition that seems to be spreading. But when I started teaching Ruby on Rails, I thought, this needs to be taught when you learn Ruby, when you learn Rails, because if you don't learn it while you're learning the language and the framework, well, then when will you learn it? I was going to teach a beginning class, and so if I teach my beginners to do it all the other way, they're going to be off on their own lonesome without knowing how to do it. And so I asked around when I was starting to teach a formal class, and I met Alex Chafee, who had done test-first teaching in Java in the late 90s. And this was startling to me. What do you mean? You give the students a test before they... What? But you have these newbies who don't know test-driven development, who are sitting together, learning this new language, and it's such an opportunity that I decided to try it. And I was really excited by Alex's enthusiasm, and we built a bunch of these test-first exercises in Ruby that I then started using in my classes. And over time, as I've taught these classes over and over again, I realized that, and these are all published on testfirst.org now, which Alex, Chafee, Leah, and I have put together. And the tests and the answers are all on Ultrasource Test First Teaching. Kai Middleton, who's in the audience, is a recent joining of our team and is collaborating with us. And so welcome anybody who wants to dive in. If you want to try any of this, if you want to teach a workshop, it's all open source. We'd be delighted to have anybody try it out. So what I found in teaching is that this works in context. You can't just throw somebody a test and have them figure it out, although people can provide their own contexts if they're really driven to learn. But I recognize that there's this pattern of things that if I manage to put this together for one concept, it works incredibly well. So when John asked me to speak, I thought this is an opportunity for me to share this with people who are interested. So it has 5 steps. So first, in a conceptual overview, what the heck am I trying to teach you? Why should you learn it? What's it for? Second, experimentation and play. So we use IRB, and I let people play with the APIs, and I teach them how to use them in IRB, which is sometimes kind of fancy. Sometimes you have to require things that you might have trouble digging up yourself, but then you can experiment with the APIs. And then I do live coding of a real-world example. And what this does is you've learned this little itty-bitty concept, and now you see this really kind of, to a new novice, complex thing. I mean, I try to find things that are focused and really show that one concept. But to a novice, seeing something in a real-world example is it's kind of, they have to stretch their brain to fit around this new concept and see the patterns and the flows. And then I give them the text first exercise, which is a very straightforward, to me, and new. It gives them a chance after they've used the APIs once in IRB, they've seen this example. This is now really the fourth time that they've been exposed to it, and they have the opportunity to execute the tests and build it. And I usually give 2 examples so that there's, if somebody finishes early, they have a chance to do another one, and people have a chance to see the concept in 2 different ways. And then lastly, one of the important things that new teachers often forget, and I forgot when I was first starting to do this, is to name what they've learned. To basically say, okay, now you've learned this thing, this is what it's called, this is what it's for. Because people get all immersed in it and then they forget all of the names that I introduced in step 1. So I'm going to give you an example of how this works. So this is my lecture on blocks. I have a little awesome diagram made by Leah Hansen about how blocks work, and you have the definition of a method that takes a block and it calls yield, and then you have the method accepting a block and its output. So this is the part of the conceptual overview. Second step, you do some experimentation. Type out these things in IRB, do a couple of examples, and you sort of get a feel for it. It's still kind of hokey because, like, what the heck am I doing here and why? It doesn't really make sense, but you sort of start to get the syntax. Now we do something fancy. We rewrite a performance monitor together. This is actually, we test drive it. We start with, how do we build a performance monitor? What does it need to do? It should report the execute. Then we write the test. It should report the execution time. It should execute a block so many times, and we write the RSpec for that. And then we do the implementation. And that's a very satisfying thing because people see something practical that maybe they've used in their other programming. Then we have the simple hands-on exercise where they just make a method that executes a block, and this is an example of a task that is then implemented by the students. Lastly, and this is really important, I say, you just learned about blocks, which are most often used for iterators, and they're used anytime you want a developer to define behavior without modifying your library. And it's really incredibly magical to actually explain what somebody just learned. No, this is like an old adage. Tell them what you're going to tell them. Tell them what. Anyhow. So, I'll repeat. TFT works best in concepts. You do a conceptual overview, some experimentation, ideally play, although it's really hard to get adult learners to actually feel playful in class. And then demonstrate a real-world example, do a simple hands-on exercise, and named what they learned. So how exactly does this work? So the teacher writes the test, the student makes it pass. And what this provides is this clear task specification. The student gets immediate feedback about what they're doing and whether they've written the code correctly to achieve the goal. It provides step-by-step guidance, and I'll show you this in a minute. And the key thing that I found to be kind of unexpected as a teaching methodology is it teaches the students to read their errors and understand what they mean. Now, you all know that coding errors are bizarre sometimes. You get these errors, and you're like, what the heck does that mean? And to be thrust into that, dealing with that error when you're doing something new that you're kind of nervous about, and you feel like maybe you won't be able to accomplish this thing, is really not conducive to learning. They've done all these studies that when you're stressed out, you don't learn very well. So what this does is before the student writes a line of code, they see the error. So there's no, they didn't do anything wrong. So they can really, they can appreciate it and learn about it. So the key point, which I think is also a good life lesson, is failure is necessary in order to succeed. As software developers, failure is just part of the process, and test-driven development just front-loads that, so you don't have to be self-conscious about it. So now for a demo. So here's a spec, which is an example of something that I might use for test first teaching. And we teach the students to run the spec. And this is, the sort of kind of the first Ruby they do after experimenting in IRB. So you run the spec, and you get this big, long, horrible error that is really frightening. And it takes a little practice to read that it says, oh, here we go, gem original require, which of course this has nothing to do with gems, as most of you know. No such file to load calculator. And then a little while later it explains that it's in calculator spec .rb1. So you look at your calculator spec, it says require calculator. So what do? Class?
Create a module.
Create a file. So now I'm going to split and create calculator.rb. So now I'm going to run the spec again, and I get another big, long, horrible error. But I've gotten to line 3 now. It says uninitialized constant calculator. Now, this is a teaching moment. Can anybody tell me why it says uninitialized constant calculator when what it wants me to do is create a class? Class names are constants. This is a little bit of Ruby arcana that it's good to know when you're learning how to read your errors. So that's telling me that I need to create a class. So then I just fix that one error, and I'll run the spec again. Oh dear. So now I'm actually executing my examples in the spec. And for those of you who don't know, this is RSpec, which is my favorite testing framework. So now I'm actually seeing, I'll have to scroll up a little bit. Here I see that I've got 3 failing tests and 3 pending tests. RSpec allows you to put in this keyword pending, which then doesn't spew output about those tests, so you can focus on the tests that are failing. So, and it puts these to-dos here. So my first failure says no method error in calculator should have a default name. So we're at undefined method name, calculator spec.rb5. So here we're at line 5. I have undefined method name, so what should I do?
Enter a blank method.
I want to create a method called name. So I'm not going to do any more than that. I just do what the test prompts me to do, and so this sort of guides me through my implementation. Now it says calculator should have a default name. It failed. Expected no name got nil, because here in RSpec language it's saying if I make a new calculator object and I call the .name method, it should equal no name. And so it's very important what I do next. I don't implement this the way that I would traditionally, which is says, oh, I've got an object, it's going to have a name attribute, therefore I want to save it off and I want to do all of these things. No, I'm only going to do what the test tells me to do. And that's my implementation. Now we have 1 passing test. Yay! So let's move on. Now we have another failing test, no method error in calculator should display number of calculations, undefined method num calculations. So we'll do the same thing here. We'll add a method num calculations. And we'll run this again, and we'll let us prompt us to say expected 0 got nil. And we'll return 0. And the first time I saw Alex Chafee do this, I thought, you are a crazy person. This is the most inane exercise. This must be purely for teaching. And he said, no, actually, it's a good idea.
So this is not just a pedagogical trick. This is how you would work and solve problems.
And I'll explain it when I get to the next method. So the next one says no method error should add zeros plus 0 and return 0. Undefined method add, def add, end. And now we'll run it again. And same test fails, but this time we get an argument error. It tells me I need 2 arguments. I'm just adding 2 numbers. So I'll add A and B. And then finally it says expected 0 got nil. So we return 0. So what have I just done? Now, many of you in the audience might be saying, you've just created the most idiotic implementation we've ever seen for a calculator, and it won't work. But what I've just done is I've created a skeleton of my class. I can see what the methods are. I can see what types they return. I can validate my design looking at this and saying, okay, this is kind of what I need for a calculator. So now I'm not going to go through the whole thing, but I'll just show how you actually start to get to a real implementation. Here I've got another example that says it should add 1 and 3 and return 4, and this is going to force me to actually create an implementation here, because you're supposed to do the simplest thing that could possibly work. And the simplest thing that's going to return 0 when I pass in 0 and 0, and return 4 when I pass in 1 and 3 is to say this is A plus B. And now I can run this, and I've got 4 passing tests. So I'll just do one more, and this is a little contrived, but now I want to specify a name when my calculator is created. So I run this, and it says argument error, wrong number of arguments, 1 for 0, and initialize. This is actually a great teaching moment because you can see that calculator.new calls initialize. So I have to create an initialize method, which is the constructor in Ruby. And it wants 1 argument. So I can say name, and I can run that. But then I see that all of my other tests fail because they're assuming no arguments. So I have to give it a default value, which is, I'm going to give it no name. I'm kind of working ahead there. So, so now I'm back to 1 failing test. I want it to say cool calculator, which I pass in here. So now I know that I need an instance variable. So the simplest thing I can do is just create an instance variable. And return it here. And I run my test, and it passes. And now I have an opportunity to look at my code and reflect on it and say, this is a chance for me to refactor this because I actually want to say this with shorter code. And I'm going to make that an adder reader name. And now I'm going to run that, and it passes. So the tests give you the freedom to experiment with different implementations and refine your code, knowing that you've got the spec right and you've got the test passing. So what John's saying, that in class he tried to make it so that he used it as a puzzle to let the errors prompt him to do the complete implementation without necessarily looking at the spec. And I think the best, if you've written your tests really well, they'll end up working that way. Was there a question in the back? Well, this is a test that I will give the students so that they don't have to learn how to write tests and learn how to Ruby at the same time. So this is, I'm doing test first teaching first. We're kind of talking a little bit about test-driven development because we're all coders in here and some of you are already doing testing. But I use these where people who are not only new to testing mostly, but also brand new to the Ruby language. So what does test first teaching teach? It teaches the mechanics of testing as well as the test first methodology. So the mechanics of testing are really important. There's a lot of details here. So it's great for people to be exposed and to learn these mechanics when they're not actually writing the tests, because that's yet another thing to learn. They learn installing and running the test tools, which sometimes you can jump through hoops to do that. And they have their own syntax, and it's their own thing. They learn the syntax of the test outline, the describe, the nested describes, and the other test frameworks have other things like it that are called, by different names. The setup of the test, the validation of the expectations. They learn about using test helpers, how to use stubs, mocks, fakes, fixtures, factories, framework helpers. There's so much that you need to learn just to do the mechanics of testing. So this test-first teaching approach allows you to learn that stuff by osmosis because you're just running it and you're exposed to it while you're learning the language. And it's a really wonderful opportunity to separate those concerns. It also teaches you this testing methodology. How do you write code as prompted by your tests? And this methodology is really important. You want to run the test, watch it fail, red, write the code, see it pass, green, and then refactor. So people, it takes some practice for people to learn how to do that. People don't want to watch the test fail, but what this does, as somebody in the audience pointed out, is this causes you to know that your test actually fails, which is really important. If you don't run the test, sometimes you had an error in your test where the test doesn't actually fail, and then you're not testing anything. Or maybe you already have some implementation that you were unaware of, which does happen upon occasion, especially if you're working on a code base that you didn't invent. So that red-green refactor is a really important methodology, and refactor is also something that you shouldn't forget to do. Your code working is not sufficient. You want to be writing good code. You want to be writing living code that you can maintain and enjoy and be productive with. Yes?
When you were running one of your classes, do you have your students pair up?
The question was about, do I have my students pair up? And I usually encourage people to pair up, but I've found that when people are first learning, they're very hesitant to do that. People really want to own what they're doing and do it themselves. So I suggest it, but most people don't really want to pair when they're just acquiring the basics of the language. That's a good question. So you learn a lot about testing with test-first teaching, but not test-driven development. That, as I said, it's not really about testing. Test-driven development is about design. It's about focus. It's about separation of concerns and how you focus your attention and your time. It's about collaboration, and lastly, it is a little bit about testing. So TDD is really, in my mind, mostly about the design process. In order to write your test, you have to understand the problem. And I think this is why it's hard. It's not that test-driven development is hard, it's that design is hard. And it forces you to write your code after you've designed it. Where a lot of the time, using old-fashioned methodology, you can just go ahead and write your code when you don't really know what you're doing. You don't really know how the underpinning libraries you're using work. And you don't really know what types you're going to return, and it kind of works sometimes. And, that can be really exhilarating. But it's much more satisfying when you actually know what your code does. That sounds obvious, and I say it with humor, but I have myself been guilty of hand-waving my code into existence. So TDD forces you to really understand the problem. The test, as we saw earlier, it really specifies the interface to the code, and I think, as most of you know, having a well-defined interface, it's really more important than the details of the implementation. If you have a well-defined interface, then you can change the implementation. You can optimize all of that behind that facade. And the other thing is it really encourages modular design, that you know what the dependencies of your code are, and you sort of naturally create a separation of concerns. TDD also helps you focus. It separates the development phases clearly because you have different activities in those different phases. You specify requirements in words. You do it yourself if you're, a one-person shop. or you get it from your product manager or your client or your business owner, and those requirements, usually happen in the conversation space or document space. The design happens in the test framework. And if you get to the test framework stage where of writing your test and you don't really understand what it's supposed to do, you're in the wrong phase and you need to go back to the space of conversation and documents and words to figure out what you're trying to achieve. And then you can write your specification in the test framework. And then it clearly makes sure that you've done your design before you move on to the implementation. And then the implementation is usually much more straightforward because you've thought through the problem. It also, as I think Rich mentioned, you write all the code you need and none of the code you don't. It's very tempting to make up solutions that you don't need. And you think, oh, I'm right here. I'll just add this that I might need later. And you might need it later, but chances are you will need it 3 months later or 3 years later. And meanwhile, you're dragging around this code that doesn't have tests that you have to maintain, that it might have bugs in it. And 3 years from now, you've forgotten what you wrote. And maybe it's not useful, but it just creates uncertainty when you think you're creating confidence. Yeah, I think typically people, you write it in little bits. You don't write, and that's kind of the collaboration point. You write just a small amount of tests, and then you implement those tests, and it creates this check-in moment. Yeah. So you can check in something that fully works that might not be the big idea. It's not the whole feature, but it's one little encapsulated chunk of functionality. And when you're done with that, and then you can check in and move on, and it creates, I ran these ideas by Wolfram Arnold, who I've paired with a lot, and he brought up this point, which I thought was a really good one. It wasn't one I reflected on before, but as soon as he said it, I knew immediately that it was really true, and it resonated with my experience. So it also creates this natural documentation, which is great for collaboration. If you want to understand what your colleague did and how their library works, you just look at their tests, and then you know exactly how it works. And if there isn't a test for something, you know that isn't well-defined behavior. And you can write a test, or you can, check the implementation, or you can ask your colleague, but you naturally have this documentation without the, oh my gosh, Joe never writes his docs. You have, this wonderful way of really clearly creating transparency in a team collaborative environment. And lastly, TDD helps you test. So you create these high-quality tests, as we've talked about a bit, because you get the verification of failure conditions. You know that it's red before it's green. It avoids false positives, which you can frequently get in a test last situation. And you don't know that your test actually has no value because you've never tested the test. And then, what's really awesome, at the end of the project, you have your tests, and you don't have to do that part because you already did it in the design phase, which is one of the fun parts of the project. So the having tests means you can rerun them as you add features. And before you go on to the next point, I want to show a slide, a great intro to my next slide. This is a picture that Alex Chafee always draws, which is the difference between how productive you are with traditional methodologies and TDD. And so for TDD, productivity is almost flat. It trails off a little bit as you add features. With traditional methodology, you're very productive at first, but then, and I added these, you do feature 1 and you're very quick to get feature 1 out, and then feature 2, and you start to see a loss of productivity as you have to go back and verify that feature 2 works, whereas John says that, when you have tests, you just run the tests, so you know that it works, or you discover it's broken. And then you add feature 3, and then all of a sudden feature 3 is interacting with 2 and 1, or if you're really unlucky, there's some subcomponent that you've broken when you've added feature 3 that breaks both of those, and feature 4, and now you're underwater, and it just gets worse over time. And I've been in a lot of these situations. I was a developer for almost 20 years before I did test-driven development, and I worked on large code bases, and you get to a situation where you're very concerned about making changes, and rightfully so, because one change can jeopardize your whole project. And I've worked on projects that go out to hundreds of millions of people, and a bug can have pretty serious impact on that type of an audience. And so you start to do these things like, oh, we always have to make sure that we upgrade our libraries at the beginning of the development cycle so that we go through many test cycles before we ship. Because otherwise, because you change something in your underpinnings, and then that can be a subtle bug that you don't find for, a couple of iterations. And you have to have these long beta cycles. And you have to be just very worried about and conservative about the changes you've made. And instead of, and it creates this mode of being really afraid. And you have a very different environment. I felt like being involved with test-driven development and open source, I think open source contributes this to as well. It's very liberating because suddenly you can just upgrade to the new library, and if your tests break, then you fix it or you revert, and if your tests don't break, then you can keep moving. And it's a wonderful thing. Wolfram Arnold draws the reverse of this, which I thought was interesting if people think of it a different way, which is you've got dollars per feature on the vertical axis and time over here. And so the TDD line, it gets slightly expensive over time. And then the blue traditional line, it gets very expensive very quickly. So I thought this is interesting. They're the same graph, just inverses of each other. I wanted to just point out, how do you start doing TDD when you haven't been doing it? This is really challenging. Sometimes you have a code base and you want to start this, but how do you start test driving something you already have? One thing is to build some tests before you refactor or upgrade. You just do some broad brushstrokes. I want to make sure these things work. And then you have a little bit of a cushion. You have a double check. And you map out, I'm going to spend this much time because that's going to make me feel safer. And by upgrading, I mean upgrade some dependency, a gem, or something you're using. You test drive bug fixes. Anytime somebody reports a bug, you write a test for it, and that increases your coverage. The key thing is to write tests for anything you worry about. If you're about to do a deployment and you're like, oh, I better do it on a Monday and be up early on Tuesday because I'm really anxious, you think about what you're anxious about and write a test for that. And then you won't be so anxious. Continuous integration is essential. This is something that just totally saves you. You don't have to run the tests yourself. You can run the tests. You should run the tests yourself, but you can double check that everybody is thoroughly running their tests. If you have a long test suite, as some people do, if they're doing browser-based tests, then you only have to run the tests on the area that you're working on. And the key thing is that you can run the tests in an environment that maybe more closely simulates production than what you have on your desktop. Because sometimes you'll have test failures that happen only when you go to production, only when you go to the production environment, because it's maybe a slightly different OS or something, a slightly different database, because you can't get everything on your development machine. And something that's really hard to do at first, but feels really great once you get the hang of it, is remove unused and untested code. So if you're not using something, just delete it. That's what version control is for. And when you've been used to this, fear-based development, deleting stuff is really hard, but it's awesome. So, to recap, test-driven development is about design, focus, collaboration, testing, and it's more fun. So you can check it out at testfirst.org. You can come collaborate with us at Ultrasaurus/testfirstteaching. There's upcoming classes at Maracana who are graciously videotaping this event. Wolf's teaching my May class because I couldn't make those dates. And then I'll be teaching the class in July again. Wolf's an awesome teacher too, so if you want to get more into this, it's a Ruby and Rails 101 class, but it uses test first teaching throughout it. And if you know somebody who wants to get into Rails, it's a great introduction that really gives you the foundations. This is a little bit about me. I have a startup company called Mightyverse. You should all check it out and download our iPhone app. It's not quite a minimal viable product, but we're working on it. I have a consultancy called Blazing Cloud. We have classes too, usually evening, weekend classes. My alter ego is Ultrasaurus, which I blog and Twitter on. Questions? So the question is, why is RSpec my favorite? So you ask versus Cucumber. I evaluated RSpec against test unit and shoulda. And I thought really hard about what the right answer was for testing. I was using RSpec in my practice in my development practice because I thought it was easiest to read. I have up on Ultrasaurus somewhere. Let's see if people are interested, I'll show you this. So I have this test framework comparison. I'll just show you the tests themselves. This is on Ultrasaurus test framework comparison if you want to play with it. There are 3 tests written in each framework for Pig Latin. And so there's a spec, which is RSpec. There's test Pig Latin, which is test unit. And there's test shoulda Pig Latin, which is the shoulda framework, which is based on test unit. And to run test unit, you write, you do Ruby, Pig Latin, not RB, and you get output that looks like this. You get the sort of familiar, all the test frameworks have this little indicator of tests, and then it'll say a failure and where it failed, and then what I think is a little verbose, what it expected. And shoulda is even more challenging that way in giving fairly verbose output because it's living within the constraints of wanting to be in test unit. And then RSpec has a very concise output, and it has this ability to do pending, which I hear test unit, the latest version of test unit has pending also. And then I think this is much clearer to read. And that's my bias. I feel that in my practice, what I want to optimize is my ability to find an error quickly. I also don't mind that RSpec reads not like a little different, that it says .should and there are spaces in funny places. Like I don't mind that. I find, I can learn to read anything. And after a while, it sort of sounds like English. But I was tempted, so I'll show you. You've seen RSpec by now, so this is the test unit version, and here's the RSpec version, which end up looking fairly similar. And shoulda it has the wrapper that looks like here. I'll just bring it up instead of just saying it. All right, so here's the shoulda one. So should incorporates the sentence-like description of a test, which RSpec has. Of course, now test unit has that too. In test unit, you can now say it something with a sentence. It uses the same asserts that test unit has, and shoulda has a very good macro syntax for encapsulating a bunch of tests and assertions in one line. And the creator of shoulda said that he wanted to make it so that that most of the time you had one line of test for one line of code, that you didn't have one line of code. He didn't like how much he had to write tests. And the bias of RSpec is making things more clear and focusing on very clear output. So So here's RSpec down here, where you've got these dot shoulds, and I find those to be very readable, but some people don't like, oh, it's too magical. So the one thing that made me consider test unit or shoulda was that RSpec was really magical. In fact, I made a tentative decision that, okay, it's too much to teach this weird syntax. And I was like, and then I went to prepare to teach this, which is test unit. And I said, okay, here's a class. Everybody understands that. It's subclasses, test unit. And I have these methods. And then I have this Ruby file, and I just say Ruby test pig Latin. So I've got a Ruby file, and it's got a class in it, which declares my class, and when I run it, it executes my tests. How do I explain that to Ruby novices? And then I decided that every test framework has an awful lot of magic, and you better be a very, very sophisticated engineer if you want to even try to understand exactly what the test framework does and how to implement it. So I settled on doing RSpec because I like the output. I think the tests are really readable, and I decided not to teach people to understand the test framework in a novice class. The long answer for your short question. So the question is about if you have a really complex problem, does it really make sense to approach it this way of doing a little bit at a time?
Yeah.
And I think that some people in the Agile community might disagree with me. I think some thinking about the big problem is really merited up front, that you want to actually think about what you're trying to achieve and step back and, look at it a little bit and kind of know where you're going. I mean, some people say no, because you might not be going there later, so why are you, focus here. At least that's what I've read. But I think some of that is good and important. And in any case, it makes me feel better. It makes me feel like I know where I'm going, even if I have to revisit that. But I think the argument is not to do that for a protracted length of time. And that even if you settle on an approach, usually there's some building blocks that you know you're going to need. Like, oh, I'm going to write a compiler, but, there's these utility things that I know that I need. Like I know I'm going to need a little data structure that handles blah, and it's going to have, this behavior. So I'm going to test drive that component because I know that my approach is going to require one of those things. And so you break up, your plan into pieces that you can chunk off that then you work together. And I think that's how I would approach a complex problem with test-driven development. So I think that's Michael's observation was just about engineers who have not test-driven their code, who are afraid to refactor because it might break. And you might have to chase down crazy bugs. And that's really what flattens out the TDD curve, is not just that you have tests, but that your tests allow you to make code that's alive, that suits the problem at hand, which may be different here than it was here. Typically, by the time you're at version N of a code base and it's been around for a while, what you did in the first few weeks, probably weren't the right decisions. Whether or not you were following a big master plan or making it up as you go along. And I think that's one of the Agile points, is that, we can't predict the future, and everything changes. I've done just a little bit of TDD in JavaScript. I've used Jasmine, which I think is a delightful framework. It has RSpec-like syntax and nested describes. It was written by, it comes out of Pivotal, and we put together this WebOS workshop, and we used it for Palm WebOS front-end work, but a lot of people are using it for web JavaScript as well. So, and I've talked to people who've used a number of different frameworks, and they really like Jasmine. I've also used Selenium for in-browser testing, and I liked it. I don't I hear that it has a lot of setup problems. I didn't experience them, but it was much nicer than I expected it to be, because I come from the, shockwave and flash kind of world of everything is very closed and it's hard to get in there and test stuff, and I didn't expect test-driven development for UI to be really that to really work that well, especially when it's running the whole browser. But it was pretty lightweight and it worked pretty well, and I like that. So the other JavaScript frameworks that I've heard about, there's Screw Unit, which appears to be one of the older ones, and JS Spec are widely used. Water, W-A-T-I-R, is another browser framework that people speak highly of. Anybody else have any favorite JavaScript frameworks that I'm forgetting? But it seems that the JavaScript, I don't know whether I could say that the JavaScript community is aggressively adopting testing, but there is a core test-driven community within JavaScript that seems to be developing a lot of tools and making great progress in that evolution. So I'm excited to do more of that. So the question was, seeing this move towards having fancy UIs written in JavaScript, jQuery, mobile UIs, and having the back end being primarily web services, and is that a trend that other people are seeing? I'm certainly seeing it. I consider the mid to late 90s to be a weird aberration in time where we took something which was about displaying documents that were hyperlinked together to create the World Wide Web of information, and we turned it into a web application that strung together web pages that were no longer about content, but were about little pieces of UI that went back and forth to the server every user interaction. Like, who thought that up? It was something that came out of the ubiquity of the web, not out of an architecture that anybody said, yeah, this is a great UI design. So I think that, to me, it seems like I don't know which technology is going to win and exactly how it's going to play out, but I think it's much more natural to do a bunch of interaction purely on the client and only go to the server when you actually need to go to the server, not just to display a message to the user. All right, I think we're out of time.
All right, thank you very much.
Thank you, everybody.
Terrific.